Welcome back, guys. Welcome back. Welcome back to the continuation of inverse functions. So, right now on this video, I'm going to focus on the exponential function, the inverse of an exponential function. So, when you look at the equation, which is from your grade 11, when you look at the equation of your grade 11 exponential function, if you remember well, you had a times b to the exponent x minus p plus q, where your a modifies the position of your graph, which tells you that the graph will either be above the asymptote or below. So when a is negative, your function will be below the asymptote. When your a is positive, your function will be, or your graph will be above the asymptote. And your b modifies an increase or decrease of your graph. So yeah. And p modifies the horizontal shift, meaning from whether it's been shifted to the left or to the right. And your q is basically the asymptote. And it is also a vertical, or it's also a vertical shift, meaning up and down. So this is grade 11. I remember repeating this in another video. So this video specifically will teach you how to convert an exponential equation onto a logarithmic equation. So a logarithmic equation or function is nothing but an inverse function of an exponential. But when you talk about a logarithm is basically what? An exponent made the subject of the formula. So logarithms are exponents made the subject of the formula. That's why when we have y is equals to 2 to the exponent x, when you're going to do an inverse function of exponential, you'll have to swap. Remember, then when you swap, then you make y the subject of the formula, then you'll have something of this kind. So before you can have something of this kind, you have to first understand the concept of logarithms, how logarithms work. So right now I'm going to teach you how to make the exponent the subject of the formula, basically how to find the logarithm from exponential equations. So this is an example here. When you look at this 9 and the side it's equals to 3 squared, basically you have a 9, you have a base 3, and you have an exponent 2. The whole thing here, which is 3 squared, is what we call a power. So I can just do this and say this is more like power. This is a power. But 3 on its own is just the base, and 2 on its own is what we call the exponent. So this is a power, base, and exponent, right? So when you say this equation, you're going to say 9 is equal to 3 squared, or you can say 9 is equal to 3 to the exponent 2. And if you want to use the word power, you'll say 9 is equal to 3 with the power of 2 to the exponent 2 with the power of 2. Make sense? So when I change this onto a logarithmic equation, I will have to make 2 the subject of the formula. If I want to make my exponent the subject of the formula, I will just say 2 now is my subject of the formula. Being equated to, I will introduce the log. And after introducing the log, what about 3 and 9? 9 will be here and 3 will be down there as a subscript. Something that is down there is a subscript. Okay, like for an example, if you remember in chemistry, those who are doing chemistry, if you have H2O, let's just say H2O. This 2, we call it the subscript of 2. It's not an exponent, it's not at the top, it's at the bottom, it's a subscript. So this subscript here is basically the base. So what was the base in the original equation where the exponent was an exponent? On your logarithm, the base will still be the base, and 9 will be from the subject of the formula. So you say 2 as an exponent, you make it the subject of the formula, you write your log. What was the base will now be the base again, and the rest is algebra. It's obvious. So when we call this, we say 2 is equal to log 9 to base 3. We don't say log 3 9, we say log 9 to base 3. 2 is equal to log 9 to base 3. Makes sense. So how do we convert them? Let's say for an example I can make other examples. Let's say I had let's say they say an interesting example would be 25 being equated to 5 to the exponent 2. If I want to make 2 the subject of the formula, these are your examples. If I want to make 2 the subject of the formula, I will say 2 equal to, right? 2 is equals to what? Log. What was the base? Remember, what was the exponent will now be the subject of the formula. And what was the base will still be the base. Make sense? Then the remaining part here will be what was the subject of the formula, which is 25. So 25 is 5 squared. So now you can even test it and press it on your calculator. You'll find it just below on the underneath on the on button on your calculator there. You will see the log. Then just press it, and where there's a base, you punch in 5, and then here you punch in your 25 and press equals to. You'll see that it's going to be equal to 2. So we use this to solve for exponents. Remember in grade 10 and 11, when you had something like, for an example, if you have 3 is equal to, let's say 3 to the exponent, or let's just say 3 equals to, or let's say 3 to the exponent x is equal to 27, and they say solve for x. All you had to do was 3 to the exponent x equals to 27. When written in prime base, it will be 3 to the exponent 3, right? And when we had numbers of the same base, we equated the exponent, which was going to be x equals to 3, right? But now with logarithms, we now can solve exponential equations where the bases are not the same. For an example, if you were to have 2 to the exponent x is equals to 7, for an example. Now you see, you can never represent 7 with a prime base of 2. But we want to solve for x. So what will be the value of x? You make x the subject of the formula, you introduce log, and you say what was the base here, still becomes the base here. What was the subject of the formula will be here. So x now will be equal to log 7 to base 2. So you can punch this on your calculator and find the value. And once you have found the value, you can save it on your calculator. Then use the saved answer and just cast it and substitute that answer onto x to see that 2 to the exponent, that value is equals to 7, and you can even test it. So this is how you make an exponent the subject of the formula using logarithms. So a logarithm basically is nothing but an exponent being made the subject of the formula. There are other definitions in textbooks and on Google and what's so not, but this is just me simplifying the definition for your own understanding. Okay? So yes, this video is just about this, how to make the exponent the subject of the formula using logarithms. See you on the next video where we are now going to convert an exponential equation onto an inverse equation, or an exponential function onto an inverse of it, which is going to be a logarithm function. So a logarithmic function is nothing but an inverse of an exponential function. Are we good? Bye-bye. Drop the mic.